Introduction to lathe. In this video, we will be discussing about the introduction of the lathe and the history behind this. Now we can see a 3D model of the lathe. The lathe is one of the oldest machine tools invented and came into existence from the Egyptian tree lathes. The lathe is a machine which removes the material from a job and reduces the job to the required shape and size. This is achieved by rotating the workpiece while the single point cutting tool removes the material by traversing in a direction parallel to the axis of rotation. Working principle of a lathe. In this video, we will be discussing the working principle of the lathe. Now we can see a 3D model of the lathe. So we can see the principal components: workpiece, chuck, tool post, cutting tool. In a lathe, the workpiece is held in a chuck or between the centers and rotated about the axis at uniform speed. The cutting tool held in the tool post is fed into the workpiece to the required depth and in the desired direction. The workpiece is rotated and the cutting tool is moved relative to the workpiece. That's why the lathe is called as turning machine. Next, the construction features of a lathe. Here we will be discussing about the construction details of the lathe. First one, the headstock assembly, headstock spindle with chuck, workpiece, feed selector, tailstock assembly, dead center, carriage assembly, compound rest, apron, cross slide, tool post, lathe bed, guideways, lead screw, feed rod. The specification of lathe. Here we will be discussing about the specification of lathe. How we will specify a lathe. Headstock, tailstock, lathe bed, swing of workpiece over the lathe bed, the height of the centers measured over the lathe bed, swing over carriage. It is a swing or diameter over the carriage. Distance between the centers. Maximum job length in millimeters that may be held between the centers. Overall length of the bed. Bed length in meters, which includes the headstock length. Lathe bed. Here we will be discussing about the lathe beds and its components. The main component of a lathe beds are bedways. Bed is the base of foundation of the lathe. It supports the other parts of the lathe. Inverted V bedway, flat bedway. Inverted V bedways and flat bedways provide support for the carriage and tailstock movement. Headstock. Here we will be discussing about the headstock. We can see the parts: headstock, workpiece, chuck. Headstock provides a mechanical means of rotating workpiece. Hollow spindle. Headstock consists essentially of a hollow spindle. Power source, that is the motor. Power transmission, that is a belt drive. Gear mechanism. It also consists of a mechanism for driving and altering the spindle speed. Back-geared headstock. There are mainly two types of mechanisms: back-geared mechanism and all-geared mechanism. The back-gear arrangement is used for reducing the spindle speed, which is necessary for thread cutting and knurling. Back gears B1 and B2, L, pulley pinion P1, bull gear G1, spindle, lever, lock pin, cone pulley. There is a step cone pulley on the lathe spindle which can freely rotate. A pinion gear rotates along with the pulley. Back gears not engaged. Power transmitted from the P1 to G1 and spindle. The spindle rotates at normal speed. The spindle back gears are engaged now. Lock pin is released. Power is transmitted from P1 to B1 to B2 to G1 and spindle. The spindle rotates at reduced speed. This is the tailstock. So we will discuss about the tailstock now. It is one of the major important component of a lathe. Tailstock. Tailstock is a non-rotating part of the lathe. It supports right end of the workpiece. Tailstock spindle, dead center. Dead center support the workpiece. Spindle clamping lever, hand wheel, screw, bed vise, clamping bolt. Tailstock can be moved left or right over the bed vise. When supporting heavy jobs, live center is used, which rotates along with the job. Carriage. Now we will be discussing about the carriage. The carriage components are saddle, crosslight, compound rest, tool post, apron. Saddle. H-shaped casting slides along the bed vise. Cross slide. It gives the cross feed motion to the cutting tool. Compound rest. It supports the cutting tool. Tool post. It clamps the tool. Apron. It is attached to the saddle. It has gears, control levers and clutches for moving the carriage and cross slide. Phasing operation. We can see how a phasing operation can be done. Phasing is an operation which produces flat surfaces. This is a phasing tool, workpiece, chuck, this is how a phasing operation is done. It reduces the length of the workpiece. Turning operation. Cylindrical turning. Turning is the machining operation in which excess material is removed by rotating the workpiece against a cutting tool. Now you can see how a turning operation is done. The workpiece, tool, this is how a feed is given to the workpiece. And you can see the depth of cut. Next is the nulling operation. It is a process of indentation of various forms on the cylindrical surfaces. This is mainly done using a nulling tool, and this is how the nulling operation is done. A null tool is held in the tool post and pressed against the rotating workpiece like this, and you can see the surface, the finished surface, the nulled surface. You can see that it is done to provide the grip on holders and screw threads. The diamond shaped pattern. Next is the grooving operation. It is also known as recessing, undercutting or necking. This is a workpiece. It is rotated. The grooving tool is fed crosswise against the rotating workpiece. A groove is the location of the indentation in the part. This indentation can be square, round or angular in shape. The function of a groove is usually to allow room for a fitting part. It could also be the place where another part fits into this part. Grooves also provide a relief in the backside of the thread where the thread terminates. Drilling operation. It is a process of making holes on the workpiece. The drill is fed slowly into the workpiece, which is revolving in a chuck. Here is the chuck, workpiece, drill tool. The drill is held stationary and in the tailstock. This is how drilling operation is done. Next is the reaming operation or finishing operation. It is the finishing and sizing of a hole which is already drilled or bored. This is the workpiece, and this is the reamer tool, and this is the reaming operation. The reamer is held in the tailstock spindle either direct or through a drill chuck and is held stationary while the work is revolved at very low speed. The feed varies from 0.5 to 2 mm per revolution. Hence, reaming is done. Next is the boring operation. It is mainly enlarging operation. It is the enlarging previously drilled hole with the aid of a single point cutting tool called boring tool. And now you can see how boring is done. Here also the workpiece is rotated and the boring tool is held stationary like this. And now you can see an enlarged portion of the drilled hole. Next is the parting of operation. Cutting tool. Parting off is the operation of separating the finished workpiece from a box stock. The operation involves feeding the cutting tool into the rotating workpiece